today, and the theme is Earth. Okay, and our 4 prompts are going to be natural forms of climate change, feedback loops, examples, nature versus human causes, and a factor of Earth's energy budget. I think I'm gonna start with the factor of Earth's energy budget, and Riley's gonna join up really quick.
Yup.
All right. I think I'm gonna do the sun because the sun is the main thing that drives Earth's energy budget. What do you think you're gonna start with?
Well, I was gonna do the natural cause for climate change, and I was gonna start off with the glacier because you know how all the glaciers are melting, and that's increasing the sea level across the whole world. That's creating a lot of change and habitat loss for many that live on coasts.
Yeah, I'm gonna do the sun because the sun directly drives all of Earth's energy budget, and without the sun, the Earth wouldn't have its energy budget like it does to have today.
Exactly.
Yeah, another reason is Earth's energy budget is pretty much all the energy that is in the Earth and comes out of the Earth at the same time. What else do you know about that Earth's energy budget, Riley?
Doesn't the Earth's energy budget have something to do with how the ocean like relays the message of it?
Yeah, so pretty much the sun rays come in UV rays, and when they hit the ocean, it changes it into what is it? I'm missing the word right now, but it turns the wavelength of the rays to long wave rather than short wave.
Okay.
Yeah, and that makes it usable for the Earth and like warms up the Earth. And that also has to do with the greenhouse effect, because when the sun's like rays travel through the Earth and through the ozone layer in the stratosphere, they once they try to bounce back off of things that what's the word? Damn. It's pretty much, it has to do with how Earth's like reflectability, and so when the rays reflect off the Earth and come back to the same ozone they came through, they're trapped by these things called greenhouse gases like oxygen, carbon dioxide, nitrogen, methane, yeah. And so all these trap them and bounce them back into Earth, further warming the Earth. So that's why people are concerned if they keep on making pretty much Earth has its own cycles, you know, it doesn't need us. And when we start adding to its cycle and doing things to its cycle, people become concerned because like the Earth, it can do its own thing, but when we start adding factors to the the pot, it can cause some concern. So people are concerned that we're overproducing greenhouse gases, which is causing the Earth to warm. And they used to use the term global warming, but they found that term to be obsolete because climate change is a far more applicable term, and it also the Earth is always warming and cooling. That's just how it is between interglacial and glacial periods, because the Earth will be covered in glaciers and it'll be without glaciers. That's one of the assignments we did in class, showing maps of the Earth with glaciers and without glaciers. And so global warming doesn't really accurately depict that, you know, because it's just climate change. But people are concerned that all these greenhouse gases we've been producing are going to cause more climate change, I guess, and a stronger climate change, which can kind of get the Earth out of whack, you know, and out of its natural way of things. So that's why people are concerned.
Okay. Does that also have something to do with feedback loops? Going back to that, because
educate me.
Yeah. Okay, I will. So we have positive and negative feedback loops. So when you have a positive feedback loop, that means the output of that is adding to the output of the next one.
So what's a good example of a positive feedback loop?
So just like in Minecraft, I have an example from Minecraft. So say you have a minecart going in a circle, right?
Oh yeah, we gotta show that for later.
Yeah, we will, but just talking about it right now, you can take these powered rails which make it go faster and speed everything up. So those will add to it, make it go faster, and every time it gets back to its start point, it will continue to speed up.
Oh, so like when the Earth, when it starts to become hotter, it creates more weather, like clouds and stuff.
Yeah, exactly.
And those clouds make the Earth cool, and they cool the Earth. So wouldn't that be a negative feedback loop, right? That's like an example of a negative feedback loop.
Yeah, so a negative feedback loop will be when the output negatively impacts the next output.
Oh, okay.
So it's not going to continue to increase.
Oh.
Like say temperatures are rising, and then say like it keeps adding to the temperatures, and then the temperatures continue to rise over time, and nothing's making it go down. So that's basically what a negative feedback loop would be.
Oh, I gotcha. Yeah, this is my sun right here. This is an example of Earth's energy budget, because this is what drives it. So that's my thing. And without the sun, no more energy budget. That's for sure. What do you think about paleoclimates? You remember those from class?
About the past climates.
Yeah, it's really interesting how people can use the past climates to learn about and predict future climates and expect things. I think that's really cool. And how they use like proxies, like tree sap.
Yeah, the tree stumps. And
the stumps too. Like how many, like a ring, if it's bigger and wider, it means the tree had a healthier year. And
that
it
will
was
relate
warmer, and if it's thinner, it would be like a less bountiful year and colder year. Isn't that interesting?
Yeah,
and they researched the pollen also from trees, because some trees like being in cold weather and others like being in really warm weather. So they can determine what places were warm and what places were cold back in the day, because they look at the tree sap and they think, oh, like this tree sap's from trees that enjoyed warm weather, so it must have been warm here. I think that's super interesting. I really love learning that in class.
Yeah, another proxy about that is so there's like you can look at it from like if you go to the bottom of a lake, you can see different types of sediments and stuff like that, and that will all show you on what was going on from outside. Like at that period of time, like what was growing and that kind of stuff.
And then
that'll show you the climate that there was at that place at that point in time. Alright, so on the bottom screen here we have a little glacier, but as you can see it's melting, and the sea level around it's all rising, as you can see the water going into it. And then we got polar bears who have lost their habitat because of it, and all the ice and the snow has all receded to just where the iceberg is. So you can see that there. That's my example for that.
Yeah, and over here I got a volcano coming up for natural forms of climate change. Because volcanoes, when they erupt, they spew like dust and ash in the atmosphere, and this covers out the sun, causing the earth to become cooler. And it can, back in the day when the traps, like very big volcanic ranges, blew up, it actually caused the earth to be completely the weather period to change. Yeah.
All right, coming up for me on the bottom is I'm gonna make a jungle forest, but I'm gonna use it to demonstrate how deforestation is affecting many habitats for many different species of animals.
Yeah. My example is going to be of the Siberian traps that actually back in the day they dispersed so much methane and the earth that it changed the temperature and the way Earth was working at the time. And really volcanoes, they don't really do that, because I mean the amount of methane and like gases they produce don't really affect anything. But this Siberian trap was so big and so massive and erupted for so long that they believe that all the methane and other elements it produced caused big implications on the earth back then and even today.
Wow, that's interesting.
Mm-hmm.
As you can see on my screen now, we have a little forest, just like forest. But we have all these animals in here, and as you can see, they're all going away. They're all going to a different place because there's not enough here to sustain them, because of deforestation and how that's taking away from many different animals' homes, and that's making them have to go somewhere else. And some species are able to adapt to it and change, but a majority aren't, and that will lead to many habitat loss, and also some may or may not go extinct because of that, because they're not able to adapt to their new climate, which will force them to leave or even go extinct.
Yeah, up here I finished my diagram of a volcano, and yeah, and now I'm gonna be on to human versus nature and climate change. And I'm thinking of building a smokestack because burning fossil fuels and the fracking of oil is actually one of the main things that contributes to climate change today. Because it releases so much natural gas into the atmosphere. Many people were actually concerned back in the day that it would accelerate the climate change to the point where it would become extremely problematic, but it is yet to, but because we have made countermeasures, actually slowed down on or not slowed down, but become more mindful of what we were burning, how we were burning, what we were doing. And also, this could be used as an example of how climate change has changed since the Industrial Revolution. Because before the Industrial Revolution, I mean, people could affect the climate, but not as majorly as they could back comparatively to now. Because now, when we can burn fossil fuels and everything, that wasn't a thing back in the day, you know. We couldn't frack for oil, we couldn't drive our cars around. None of those were things back in the day, you know, and before the Industrial Revolution of pretty much the entire world. But ever since cars came around and oil fields, all sorts of things, electronics, creating electricity, the world has completely changed, man. Everything has honestly been changed. I find it hard to believe that any part of the earth hasn't been changed by the Industrial Revolution, you know?
Yeah,
and the climate is a big example, you know? And the climate has changed so much, it's become so much warmer, and people are honestly concerned. I mean, species just like those polar bears are starting to become endangered, and all sorts of birds and species from the Amazon, the biggest rainforest in the entire world, are starting to disappear and dwindle because we require so much paper and products from trees that we cut down all these trees and even make more farmland from these trees because of the Industrial Revolution. Because before we weren't really doing that. I mean, we were cutting down trees, but the demand has just skyrocketed, you know?
No, completely.
It's gone crazy, and that's caused habitats like like the rainforest and other places where all these big cities are to disappear almost.
Hey, where are those paintings from?
Oh, those are signed by a famous Texas player.
Oh, really? Where in Texas?
Yeah, Austin.
Austin?
It's actually a really cool place. Yeah, I actually love researching about Austin.
Yeah, I wonder if there's anything going on there with climate change.
Oh, really? Yeah. I mean, honestly, for Austin, it's in a really interesting spot because Texas is known to be real warm, and
Yeah.
if the future continues, it's only gonna get warmer. You know, it's only gonna get hotter. and it's actually really close to the Colorado River. And in Texas, especially that area, rain is super frequent. As what we've seen, rain's gonna start becoming more frequent. So I think Austin's got a lot coming for him. I think
Oh wow.
flooding.
Really flooding?
Flooding could be a problem in the future, yeah. Because
in
it's such a
Austin?
low-lying area and it's near such a big river like the Colorado.
Oh yeah, that's right.
And also, I think heat waves are definitely going to become a factor in Texas in general and in Austin. But it's good though. They've been super on it for carbon footprint, and honestly, Austin's an amazing city. It's super up to date, super modern, and growing like no one else and nowhere else. So I think they are ahead of the bell curve for sure.
Okay, that's great.
Yeah. And I think they've definitely, I mean, all of Texas has looked towards renewable energy sources, especially with how popular fracking and oil drilling used to be there. So yeah, I think they're ahead of the bell curve. But also the urban city effect, I believe. I'm not sure if that's the correct terminology, but pretty much it's an effect where the city, asphalt, it absorbs more heat. So like comparatively, like Austin probably used to be like a grassland maybe or something like that. And the grass, it kind of had a cooling factor, on the area surrounding it. But now since it's all asphalt in like the big city, the asphalt absorbs, like, when you're a kid and you're running around playing and the asphalt's super burning hot,
Yeah.
That's a good example because Austin is covered in new cities, new buildings, new everything, to be honest. And that asphalt heats up and can hold energy, hold heat. And so this causes the city area to become a lot warmer. I think that's going to be another problem for Austin, including its heat waves. It's kind of like a double whammy in a sense,
Yeah, no, I get that. Let's just hope it doesn't come down to that then.
But yeah, Texas is definitely going to foresee some more rain in the future. So I think we've got to stay updated on how flooding is down there and how much rain and precipitation they're going to be getting. Yeah, this is my example. I'm almost done. Hold on, let me finish this completely.
Alright, I think it's about time for us to wrap up this build battle.
No, we're not done yet. We still need to focus on a couple key points. Here, you want to take one of my prompts?
What's another one of your prompts?
Another one of the prompts. What can you take here? So I've done a natural form of, that was my volcano. What'd you do?
I did a glacier, and I did deforestation and habitat loss.
Oh, yeah.
And then I have
I gotta do my feedback.
I got a feedback loop right here. We have a negative feedback loop.
Explain to me how that works.
So look, I give this polar bear a push, and he starts going around. But look, as he gets back here, he starts slowing down.
Okay.
Slowly starts slowing down, and eventually he's gonna come to a stop because he doesn't have any more momentum pushing him.
Oh, interesting.
So his output is no longer giving him more and more. It's slowly taken away from him.
Yeah, so your push, it won't affect another push.
No, it will not.
Yeah, okay, this is my example as humans versus nature on climate change. This is a smokestack, and this has been a big symbol for climate change in the recent years in general. People associate big smokestacks like this as a big thing and as almost a daunting thing for climate change. And let me make my feedback loop. What am I thinking here?
Just gotta get some power rails.
So this right here is my example of a positive feedback loop. See, this rail, this powered rail, is gonna keep on pushing. So every time this polar bear comes right here, from me powering this, it's going to keep on pushing. Meaning that the loop is going to keep on building on itself and actually gaining momentum as the polar bear goes around. So it's just going to keep on adding and keep on continuing the loop. So that's my example, yeah. Wow. Okay, so we got the sun right here. We got an example of natural climate change, a forest fire. Wow. And what would this be?
That is a glacier.
Oh yeah, this is a
glacier.
natural form of climate change with the glacier dissipating and slowly melting. This is my form of natural climate change, big volcano. This was my energy budget. Oh, what are you thinking for your energy budget?
This can also be related to the energy budget because
Tell me about that.
So we can say, just look around. It's not the greatest, but
Okay.
outside of this we have an ocean, right?
Uh-huh.
So the ocean is going to relay your energy budget.
Mm-hmm.
That's going to change the wavelength. So that's going to change and make.
So it's going to affect the input and output of Earth's energy, which is its budget.
Exactly.
Wow.
So we can just use that as a form of an ocean.
Wow. That's really cool, yeah. I think this deserves some fireworks. I think we're all good. I think we're all done.
Might as well back out for this one. It's not going to keep going.
Good battle. Coach Heieck, let us know who won.
I say it was me.